the screen here. So let me put this over here. Then let me share this other screen. All right. So you guys can see that, right? Can you see that? Perfect. So here's what I want you to do. I created this thing years ago because I have such creativity. I named it the chart because it's a chart. That's kind of math creativity right there. But what I want you to do is I want you to make this chart, and I want it to specifically look like that. Okay, so I'll give you a second to make that chart on your, and this is going to shape a lot of what you did in the last two assignments and what you do in today's assignment on Delta Math and what we do tomorrow. And tomorrow we'll do a thing on Desmos, and then really kind of shapes a lot of this unit actually. If I could sum up this unit, with the exception of a couple of things, this chart sort of takes care of all of it, and we'll add to it, and we'll do a bunch of things with it. Okay. So you guys have this chart down, something like this. It's a pretty basic matrix, 4 rows, 3 columns, labeled at top, F, F prime, F double prime. Those are generic. I mean, I could change the letter. I could make it P, P prime and P double prime, or Q, or I could make it all kinds of things. So that's pretty generic. So don't get tied into that name, meaning anything other than function, first derivative, and then the second derivative. So you already have part of this down on in your notes, and we're going to write this chart several times throughout this unit. So if F is increasing, think about a graph that's going up, and think about the first derivative, which would be the slopes of the tangent lines to a graph that's going up. All of those slopes would be positive. So the first derivative is going to be positive. Consequently, if you use this one and you say it's decreasing, then all the slopes are going to be negative. So if a derivative changes from positive to negative values, you know a function is going from increasing to decreasing. There's nothing really we're going to get in this box right here or this box right here. We're not going to get any information in that. If you think about traveling, think about this being like a road map. If you're traveling from this row to this row, so if you know f of x goes from increasing to decreasing, you know its derivative graph would have to be going from positive values, which would be above the x-axis, to negative values, which is below the x-axis. What you get is you get a relative maximum here. Now, if you're like, I have no idea what a relative maximum is, that means you probably didn't look at the videos in the last 2 assignments, because we talked about them in there. So you maybe need to go back to that, but think of it as a peak or a hill in the graph. Now, if you go the other way, so if you go from the second line to the first line, so if you go from the second line to the first line, and this is a relative maximum of F. This one is a relative maximum or minimum, sorry. This one would be a relative minimum of F. Because think about going from that second line to the first line. You're going from a decreasing graph of F to an increasing graph of F. And the derivative graph would be going from negative values, which are values below the x-axis, to positive values or values above the x-axis. Now you can do the same thing. If you think about like the second derivative is just the derivative of the first derivative. We essentially could write the same things in here, increasing positive, decreasing negative in those. Now, you don't get to cross out this other part. This part we're going to fill in later. So don't cross these out. Just know that the part that I highlighted right there, we are going to fill in what that means later for the function. But for today's work, what you need to know is if you're going from here to here, there is a relative maximum of F prime. For the same reason, going from the first line to the second line, there's a relative maximum of F. Going from the third line to the fourth line, that would be a relative maximum of F prime. And going from that line to that line, this is a relative minimum of F prime. Okay. Now, if you would like to, you can stay on this. You can go off this call and you can go on to the Delta Math assignment that's for today, and you can start working on it because I recognize this is an asynchronous day and you guys have been on Zoom a lot probably today. So if you want to go off and do the Delta Math assignment, feel free to exit this call. If you want to stay on and do a couple problems with me, I'm happy to sit here and do some problems that look like your Delta Math. Okay, so you make that choice now.
Mr. Alquist, I just had like a quick question.
Yeah.
It's like not really about like any of this stuff.
Okay.
For like the problems where it's like asking you about like to give you like an interval, like, or they ask you to give a certain interval where like the certain thing is true, like how do you know like what brackets to use exactly?
Yeah, it's really hard to say. So I'm going to answer it in two different ways. One way I'm going to answer it is follow the example. If it's on Delta Math, follow the examples that I did on Delta Math. Because that's one thing I would just say is just follow those examples. As far as AP goes, historically, you have never been penalized for giving the brackets as open brackets. There are times when you're penalized for giving them as closed brackets, but you've never, but historically they've never penalized anybody for giving open brackets. So
like you would say like for like AP stuff, usually just do the open brackets then?
Just leave it as open brackets. You'll probably be safer there.
Okay.
When we get to the AP classroom stuff, bring that up again because then I will explain it a little bit more. But I noticed that on some of the AP or some of the Delta Math assignments, they used open brackets and some they used closed brackets, and they're pretty rigid on their grading, right? I mean, you either got it right or wrong. But in the AP grading, the answer key may show something, but there are a lot of other variations of it that will be accepted that are kind of like a minimum thing. So at this point, if you don't remember what to do with what on the AP problems, if you left them as open brackets, you're probably much safer.
Okay.
On Delta Math, that's not quite the same.
Sounds good. Thank you.
Yep.
I was just actually about to ask about that. So
Yeah. So
I'm good.
Delta
Yeah.
Math, I would just say, Adam, I would say follow the examples that I give.
Yeah.
You know, sometimes they'll, and I think on Delta Math, I think I give you opportunities to do the problems, you got several attempts. And so if you
Yeah.
do it with a closed bracket and they mark it wrong, put open brackets on it, they'll probably mark it right.
Got
If
it.
you have the right interval, right? I mean, if you don't have the right interval, that's a whole other thing, right? And
Yeah.
then you're not even in the game. But as I was just talking to Nick, you know, when we start talking about AP specific things, if you don't know, open brackets have never been penalized, but
Mhm.
closed brackets sometimes have been.
Hmm.
So it's sort of like the rule of thumb that I always tell students is just make it an open bracket and you'll probably be safer if it's an actual AP question. Because
It's
there's
open. Oh yeah.
some debate on whether you keep the bracket open or closed, honestly.
Yeah. Okay. Thank you.
Yep.
Okay. Bye.
Bye.